the mic on. Can everyone hear me? Yes. All the way in the back. Perfect. Excellent. All right, so my name is Steve Edwards, and I'm here to talk about implementing explicit allow without getting fired. So I work at Duo Security, which is now part of Cisco Systems, and I lead their corporate security engineering and offensive security teams there. So a little bit of blue and a little bit of red. Before that, I was at Eastern Michigan University, where I led the security program there. At Duo, we have a really great product, and that's not what I'm here to talk to you about today. At Duo, we're allergic to vendor pitches, so I just wanted to tell you about some of the cool things that we're doing inside of Duo to keep the company secure. And then if you want to know more about our product, we do have a booth outside where you can stop and talk to us, and we'll give you all the details about it there. So you came to a presentation where the title included a phrase that I coined. So you may have never heard of explicit allow before. And essentially, it's a method by which all code, except that which has explicitly been, that has been previously seen, has been approved. Except which has been previously seen and approved is prevented from running on a system. So it's a more inclusive term for application whitelisting. And I didn't coin this phrase just because whitelisting and blacklisting can sometimes make people feel uncomfortable or excluded, but this allows us to expand beyond just application whitelisting, this principle, this concept. And so I think you'll see today why this might be a better term. So I'll take you through some of the ways that we've implemented explicit allow at Duo, and the way that we did it where no one ran me out of town with pitchforks. So the first thing that I want to talk about, and the secret to our success, is design. And so I'll talk about design at Duo. And I will talk about our product a little bit because we spend a lot of time thinking about design. And I'll share how those design principles we applied to the tools that we built internal to keep the company secure. Then I'll talk through where we've applied explicit allow in practice. So on our Macs, our Windows computers, our Chrome OS computers, as well as at the network level, and also for some types of authentication. I'll share a little bit about what's coming next for the things that we're building. Then I'll have time for Q&A, and if I talk really, really fast, which I tend to, then we'll have time for a demo as well. So design at Duo. At Duo, we have a strong focus on usable security. And you can see that in our product. People actually like to interact with it. And so we've taken those principles of user-centric design and applied it to explicit allow. And that's the reason we could roll out something as restrictive as these principles without seeing a lot of backlash from our end users or our system administrators. So in this presentation, I'll show you some of the tools that we've built, explain the underlying infrastructure, and the philosophy that we took in our approach to implementing this at Duo. So in other words, if you don't have usable security, people will find a way around it. In this old Dilbert comic, Mordak, the preventer of information services, says, security is more important than usability. In a perfect world, no one would be able to use anything. And then this guy's logging into his computer, and it says, to complete the login procedure, please stare directly into the sun. That's a great example of non-usable security, but that's what security companies often ask of our end users. And it's a bad experience for them, and then it's a bad experience for security teams because they've implemented something that people hate. And so if security isn't usable, it won't work. People will find a way around it. If you implement something that's so hard, makes someone's laptop so hard to use, they'll bring a work-from-home laptop. Or if you make it so hard for them to get at their email, they'll just start forwarding it to another mailbox. And we can go back and forth and try and add more controls to make it even harder and harder and harder, but that's not enabling the business. That's not, whatever your company is supposed to be doing, that's standing in the way of it instead of supporting the mission. So we wanted to take these principles and apply them to explicit allow. Duo's focus on usable security can be seen even in our staffing. At Duo, for every 5 software engineers, we have 1 product designer. So that's a lot of people thinking about how humans interact with computers and receiving feedback from people who actually use our software and people who buy and implement our software, what they like and what they don't like, and what's effective. Because honestly, that's what makes effective security. So we wanted to minimize friction. We wanted to protect people without ruining their day. And we wanted to protect people without ruining our IT department's day. If we're pushing out something to the laptops that IT manages, they're the ones who are going to get yelled at, not us. And maybe they're really good at redirecting it, and I still get yelled at. It happens sometimes. But we don't want to ruin our system administrator's day or our end user's day with any of the security that we roll out. We just want to introduce the right amount of friction when a risky action occurs. But make sure that it's not too little and too much. Just enough friction for someone to slow down and say, hey, is this really what I wanted to do? And at the same time, provide them with the best security that we can. So the winning formula, and we've applied this across all of our platforms, and I'll go through and I'll show you some examples of each. Say this starts when an action is blocked. So I feel like I'm playing Tron just a little bit. Yay! Okay, well, I liked the Tron sound effects, actually. Maybe I'll put that back later. Okay, so the winning formula is this. Any of these start when an action is blocked because, like I said, explicit allow is default deny. Everything is blocked at first. So say you try to run an application on your computer. You double click on it, and some scary message comes up and says, hey, you can't do this. Talk to your system administrator, please. A local agent will send that event to automation, and then we can start doing things. In the background, we can use threat intelligence to start scanning, if this is scanning this application against our threat intelligence feeds. To say, hey, is this known malicious right now? And if it is, we'll just raise an incident right away. It's blocked, so nothing bad has happened. It's already blocked, but we still want an incident because we don't want malware on our computers, even if it's not doing anything, because how did it get there? Maybe something else, maybe a dropper did end up getting through and landed the software there. But if we don't see that it's malicious right away, we'll prompt the end user and say, hey, did you intend to run this? Because typically we don't want software running on people's computer if they didn't mean to do it. Unless, like we, IT, pushed that to them, and then we'll have already added it to the allowed list. So we'll ask them, hey, did you mean to run this? And if they say yes, then okay. It's added to their allowed list right away, and they can double click it, and it will run. If they say no, then we'll create an incident, and we'll work through why is software running without this person's permission. Maybe it's just the Adobe updater, and they don't sign their binaries, which is really frustrating. So they didn't know that Adobe was updating in the background, so they said, we didn't mean to run this. So that's a good start. And then every single day, at around midnight, we go through our entire list of allowed software and rescan it against threat intelligence to see, hey, has something that was previously unknown been flagged as malicious? So then we can raise another incident and follow up if that's the case. And you can see with this formula, there's more that we can inject here. This is a great place to start, but you can also work in sandboxing, and you can work in actual system administrator authorization, all through this same workflow. So in practice, here's my Mac. I'm trying to run a piece of software called Stellarium. It lets you see where the stars are in the sky. And it's not allowed yet. So on Macs using Santa, we see this pop up. And it looks really scary, and there's a lot of information. Not all of it I understand. And my only button is to click ignore. That's not a great experience. We didn't build that piece. And the next thing that happens is our friendly Slack security bot says, hey, Sedwards, we noticed that something was blocked from running on your machine. Our goal is to keep you safe while enabling you to do your job. Please direct any questions to the corporate security channel, but did you mean to run this application from this folder? If yes, then you'll be able to run it again. So if I click yes, it says, okay, the application's been added. So within the next 30 seconds, you should be able to run the application again. If that doesn't work, you can open up Terminal and type in this incantation, and then everything will work. If you have any problems, again, please reach out to us, and humans will help you. And so after that, I double-click the application again, and it opens right up. So the amount of friction that was introduced here was all of about 15 seconds. I saw a scary message, but at the same time, my friend's security bot was reaching out to me to see if this is something that I really wanted to do. And as soon as I clicked it, it was just about ready for me to, by the time I could switch back and find where I'd put the application, when I double-clicked it, it was ready to run again. So this started from humble beginnings. So here's the original approach, is we started with just having people see this pop up and then take a screenshot and then also copy and paste out the SHA-256 hash because it'd be a pain for us to type it in from a screenshot and post it in a Slack channel and say, hey, I'm trying to run this. Can you please allow it? And then, you know, we'll do the threat intelligence by hand, and then we'll get it in there, and so you can see, post the hash in, and so T. Soakley there went through and said, yep, that looks good. I've added it to the list. So now you can open up terminal and type in the sync command, which everyone knows how to do because they're doing it all the time every time they run new software. And then they're good to go. And somehow, we didn't lose our jobs for doing this because everyone was so supportive. I don't recommend starting with this approach. If you can start with the automated approach, that's probably a better option. So let me tell you a little bit about the technologies that we use for explicit allow. So you've seen macOS already. And on macOS, we use Google's open source project Santa. And we've been using it for a really long time, relatively speaking. When it was released as a client with no server. And there were no servers available for it. Eventually, there was an open source software called Zentrol that served as a backend for this. So it would actually at least maintain the list of allowed software so that you could centralize that. Without that, you would have to figure out a way to put the list of allowed software on every single person's workstation as well as the Santa client. So we did that for a little while. It was backed on Elasticsearch. My experience of Elasticsearch is it's hard to keep it healthy and running smoothly, and that was the experience in this case at least. So we decided to throw it out because of its poor performance and build something entirely homegrown that's API-driven, entirely serverless, and it's actually a really simple bit of software. It serves up the list of allowed software to everyone who asks for it, and you can add new things to that software. And then it can also trigger the automation to say, hey, this person saw this block event. Let them know that, ask them if they meant to run this software. So since that was such a smashing success, and we rolled it out across all of Duo, which is about maybe 800 Macs, we decided to focus on Windows. Not because we have a lot of Windows. We probably have about 10 Windows workstations. But because Windows is a target, and we do have 10 Windows workstations. So it seemed like a problem to solve. So instead of going for commercial software or even open source software, we looked within Windows to AppLocker, which my experience in the past with AppLocker has been, I don't want to say mixed, because I think that oversells the positivity. It was pretty terrible. AppLocker is really hard to manage, and historically has required an Active Directory. So for one of my engineers, I posed this problem. Like, I want to use AppLocker to enforce explicit allow, but we don't have an Active Directory. We don't want an Active Directory. What can we do? And also, I want it to be the exact same workflow that I showed you in that flowchart. I want it to only be about 15 seconds for someone to self-remediate if they get something blocked that they need to run to operate the business. So again, it was entirely homegrown, entirely serverless, no Active Directory required, and basically it's a small agent that looks through the Windows event logs for AppLocker blocks, and then without even using Slack, it just pops up a dialog and says, did you mean to run this, yes or no? And we've already scanned it against threat intelligence like VirusTotal, Threat Exchange, Cisco Tip, and seen that it's not known as malicious. And so we pop this up and say, did you mean to run this? They say yes, and they say, okay. It'll take about 30 seconds, and then you'll be ready to go. So here's an example. So this is like on the previous slide here, this blue thing is all you get with AppLocker by default. So completely useless, not even a way to say, hey, this is the thing I was trying to run. So we created a more verbose error message in case people need to screenshot it to us and share it with us. So we say, hey, did you intend to run this? And then if they click yes, it says, hey, please wait 2 to 5 minutes. It's usually much faster than that. And then they can run the software again. So this is essentially this small agent just shells out to PowerShell and interacts with local policy objects instead of using Group Policy Orchestrator. It just changes the local policies for AppLocker. So it converts what we have in our database in AWS for what the allowed list is into the format that the policy is looking for and just pushes it in every 2 or so minutes. So Chrome OS. Chrome OS is a good place to start. If you're solving security problems on Chrome OS, you don't have a lot of other things that you need to be doing clearly. Because Chrome OS is such a hardened platform already. And so we are about 20% Chrome OS at Duo. And they're managed by G Suite, and they enforce trusted boot. But with G Suite for Chrome OS and also all of our Chrome browsers, we enforce explicit allow for plugins like Java and Flash and basically none of those, as well as Chrome extensions, and then on Chromebooks as well. Because you can run Android apps within Chrome. We also enforce explicit allow for Android apps. So we manage all of that through the G Suite console. And it's manual for plugins because there are very few that people are asking for, and for Android apps as well, because honestly, although there's a huge Android app ecosystem, at Duo, very few people are actually asking for us to add new Android apps. So Chrome extensions are the highest volume. People want a new Chrome extension every day, and they're very hard to evaluate. So we created a tool to evaluate in a consistent way Chrome extensions. The team who's adding the Chrome extensions to our allowed list is our security operations team. Someone says, I want this Chrome extension. They email the security operations team. They say, hey, I want to run eBates so I can get all of that money back. And so the security operations team gets that, and they can see it in the Chrome Web Store, but that's really all they had before we built this tool. Chrome extensions are written in JavaScript. Our security operations team isn't necessarily JavaScript experts, but even if they were, we wouldn't really want them spending all of their days like taking apart a JavaScript Chrome extension to see what it's doing. Like the permissions are kind of easily available in a JSON file, where you could look through and see, okay, well, this URL means that it needs access to everything, and this URL also means that it needs access to everything. But that's a complicated process. But even if everyone was an expert at doing all of that, and it didn't take them that much time, because they're all humans, they're all going to do it inconsistently. So we wanted to build a tool that allowed our security operations team to have a consistent and quantifiable reason for either approving or denying Chrome extensions when people ask for them to be allowed. So again, we built this entirely serverless on AWS Lambda. It's a React.js front end, and when we started, we decided, well, we could scan Chrome extensions one at a time, or we could just scan them all at once. And so we said, well, how many Chrome extensions is there? There's about 160,000 Chrome extensions in the Chrome Web Store. So we called up our friends at AWS and said, how many Lambdas can we run at once again? And we had a few discussions with them. And then finally we hit the go button, and we scanned all 160,000 Chrome extensions. And 5 minutes later, the tasks had completed, and we were like, well, what broke? But actually, we just scanned the entire Chrome Web Store in 5 minutes. And so since we've already scanned all of the extensions, we thought, well, why don't we just let everyone else see the reports too? So we made this a free SaaS tool that people can use. It's not open source. It wouldn't necessarily be a good idea for us to open source it. It's kind of aggressive against the Chrome Web Store. There aren't some APIs, so we've done some other things. Google's cool with that, but I don't think they would be cool with us open sourcing this and saying, hey, why doesn't everyone scan all 160,000 Chrome extensions in the Chrome Web Store every 3 hours?